Hello and welcome to Earthquake Tip number 29. My name is Shailesh Kumar Agarwal, Executive Director of BMTPC, and I'm going to present to you all about earthquakes, its concepts, terminologies, and how to construct buildings and structures to withstand earthquake forces through 32 earthquake tips, which are authored by Professor C.V.R. Murthy, mentored by Professor Sudhir Kumar Jain, and developed by IIT Kanpur in association with Building Materials and Technology Promotion Council, that is BMTPC. Through these tips, our aim is to spread right technical information in simple to comprehend language to our professionals who are in the field designing and constructing structures, especially our architects and engineers. But before we start, let's make a pledge that any new structure we design or build must be earthquake resistant. This earthquake tip number 29 is on what are the essential features of confined masonry houses. In the last tip, if you remember, the confined masonry technology was explained to you in detail. As explained in that tip, confined masonry system is suitable for construction of low to medium rise buildings and can be implemented with relatively low engineering inputs and technical supervision. There are countries which permit construction of confined masonry houses of up to 6 stories tall, supported by design codes and engineering inputs. Let me also tell you here that confined masonry system is not intended for use in the construction of commercial buildings or large span buildings. Let's now understand what are prescriptive guidelines for confined masonry construction of low to medium rise houses. These can be divided into three kinds: architectural guidelines, structural guidelines, and construction guidelines. Architectural configuration critically determines overall earthquake behavior of confined masonry houses, and it comprises of overall geometry and wall configuration, which will be explained to you through these figures. As you can see in this figure, the overall shape of house should be rectangular, regular in both plan and elevation. Best performance during earthquake is achieved when the plan building is rectangular, has no re-entrant corners and no interior cutouts, and have plumb vertical walls along the entire building perimeter, as you can see in this figure 1A. Figure 1B shows building with re-entrant corners, vertical offsets, and large cantilever overhangs. These buildings perform poorly during earthquakes. Another important aspect of overall geometry is plan aspect ratio, that is the ratio of longer and shorter plan dimensions. As you can see in this figure 2, it is L by B ratio. This ratio for confined masonry house should not exceed 4. Further, typical story height should not exceed 3 meters. The recommended maximum number of stories is 4, 3, 2 in seismic zone 3, 4, 5 in India, respectively, as shown in this figure 2A. As explained you earlier, even though buildings up to 6 stories have been built in high seismic regions in South American countries, however, in our country, it is restricted to 4 stories as design codes are not available. Next part of overall geometry is wall configuration, which is explained in this figure 3. Walls in confined masonry house should be aligned preferably on rectangular grid that is symmetrical in plan, as you can see in this figure. Further, all walls must run through from the base of the building to the roof without being terminated at any intermediate level. Next is openings. Openings in wall deteriorate earthquake performance of confined masonry buildings. Hence, openings should ideally be kept to a minimum in number and size. Larger openings must be confined by RCC confining elements all around. Also, opening in any story should be positioned at the same location along the height of the building. Let's now go to structural guidelines. Wall thickness required in building depends on loads and masonry strength, and this should be carefully checked. Masonry walls should be at least 110 mm thick, and their height should not exceed 25 times the thickness. Story height should not exceed 3 meters even if we are using thicker walls. Ideally, all masonry walls should be fully confined with RCC tie columns on both sides of openings and wall intersections, and RCC tie beams above and below it. You can see this in this figure 4. Earthquake behavior improves with number of full confined masonry walls. Remember, for good earthquake behavior, at least a reasonable wall density should be available of fully confined masonry in each planned direction of the building. This wall density depends on number of factors such as ground acceleration, number of stories, masonry, compressive strength, and shear strength. The reasonable wall density varies from 2 to 5%. As regards foundation, as you can see in this figure 4, right hand side, many options have been practiced, namely RCC tie beam, tie columns start from plinth beam when house has no foundation beam. They may start from foundation beam when house has plinth beam, and RCC tie columns start from foundation PCC when house has no foundation beam but plinth beam is being used. This option is used commonly. Also, minimum depth, that is height of RCC plinth beam, should be kept 300 mm. Now let's look at this figure 5, which gives detailing of RCC confining elements. RCC tie columns should be as wide as the thickness of masonry walls. Let's say 230 mm in standard brick clay masonry walls in India. Although half brick walls are used in many countries, including Mexico and Indonesia. Usually, RCC tie columns provided at wall junctions, as you can see in this figure 5a, should be square in cross section, let's say 230 mm by 230 mm, while RCC tie columns adjacent to openings should be as deep as wall thickness, but maybe less wide in wall direction, let's say 115 to 230 mm. Figure 5b and figure 5c shows connections between RCC tie beams and tie columns and between RCC tie beams meeting at the corners. In tie columns, 4 deformed steel bar of at least 10 mm dia should be provided and tied with 6 mm dia mild steel ties at 200 mm center to center. Closely spaced ties are required in top and bottom portion of tie column with spacing of 100 mm. Ties should also have hook of 135 degrees at hook ends. In RCC tie beams, minimum reinforcement to be provided is somewhat similar. Now let's go to construction guidelines for masonry houses. First of all, using quality material, good workmanship, and faithfully implementing architectural and structural guidelines as explained earlier are vital in construction of confined masonry buildings and for improving its earthquake performance. Next, the interface between masonry wall and column, RCC tie column, should be toothed. That is, bricks of masonry courses are staggered at the interface with tie columns, as you can see in this figure. This ensures that masonry walls are held snugly between tie columns. Toothing should be such that the minimum gap from bars to tie columns is 25 mm to the nearest brick face and 75 mm to the farthest brick face. Next is further maximum vertical lift per day of masonry wall should be 1.2 meter as you can see in this figure, and concrete for the tie column should be poured before the next lift of 1.2 meter of masonry wall is built. This ensures that concrete in tie column is reasonably compacted when it is hand compacted. Another important aspect is that formwork is butted against the masonry wall segment for pouring concrete in tie columns of confined masonry construction. This is the main strength of this construction, means tight fit between masonry walls and concrete poured in situ after the masonry walls are in place. Therefore, significant care is required to prepare the formwork, which is either made of wood or steel, and ensuring that gaps are plugged between masonry walls and formwork before pouring the in situ concrete of tie columns. This is all about earthquake tip number 29. You can download this tip from www.bmtpc.org. The next earthquake tip, that is tip number 30, will be on what is important in foundations of earthquake resistant buildings. Thank you for your attention.